Okay, so the last example we're going to look at is what the equation of a partial variation looks like. So for example, Cassie decides to lease a car for her new job. She makes a down payment of $1,700, and then a regular payment at the end of each month of $233 for 3 years. Write an equation to model the relationship between the total amount spent on the lease and the time. So let's look what that might look like. So let's say the amount owed, we'll call it A for the amount owed, equals. So Cassie, sorry, we're not looking for amount owed. We're looking at the amount she paid. So we'll say P for the amount she paid. So she paid the original $1,700 plus $233 every month. So we would say $233 times the number of months. So 233M. So if we just plugged in how many months have passed, we would do the number of months times 233 plus the original $1,700 that she borrowed. So use the equation to determine what Cassie would have paid by the end of the first year. So the end of the first year would be 12 months in, because there's 12 months in a year. So all we need to do is take our equation and fill in 12 for the number of months. So our order of operations tells me I have to multiply first. So I have to do 233 times 12. And I get 2,796. And then I add the 1,700 onto it. Oh, 2,796 plus 1,700. And I get that at the end of 1 year, she would have paid $4,496. So what about the total amount she would spend after 3 years? So let's do that in blue so we see the difference. So we would have 1,700 plus 233 times the number of months. So in 3 years, there would be 36 months. And we can work that out. 233 times 36 plus 1,700. And we get $10,088 that she paid after 3 years. So what would the graph look like? So you would draw, you could draw your points for every month for 36 months, but that would be a lot. Let me find room to drop this in here. Let's make this a little bit small. Let's move this over. So you could draw a point for every month for 36 months, but you don't have to. Here I just did one for every year. So it's 0 years, which was the original 1,700 she paid, and then what she paid every year, which would be 233 times 12, whatever that would be. Okay, so what do you notice? So things you could notice, you might notice that the y-intercept is the same as the initial value, which is 1,700. You could see that the slope is the same as the rate of change, which is 233. So then it says, write an equation to model only the amount of money spent on payments. So basically that means ignore the $1,700 down payment. So that equation, we could take off the $1,700 and it would just be 233M. And that equation, if you notice, looks like a direct variation where it's the rate of change times the independent variable, and that's all that's in it. So what's different about a partial variation, which is this equation right here, is it still has 233, which is the rate of change, times the independent variable, but it also has plus the initial value. Okay? So let's put it all together. So in a direct variation, the table of values should have a 0, 0 point, and it should let's actually write this out. 0, 0 point, and then increase or decrease by a constant amount. So that's what a direct variation would look like. It should have that 0, 0 point, and it should increase or decrease by a constant amount. A partial variation has no 0, 0 point, but it should still, increase or decrease by a constant amount. So the difference between the table of values of a direct variation and a partial variation is that 0, 0 point. The graph of a direct variation should start at this 0, 0 value and be linear. The difference with a partial variation is it's still linear, but it doesn't start at that 0, 0 point. So they're both linear, but one starts at 0, 0 and one doesn't. The equation of a direct variation is the rate of change. We'll call it m, or the slope or rate of change, times the independent variable, where the equation of a partial variation is the slope times the rate of change plus, we'll call it b, which is the initial value, or the y-intercept. You could call it either one. Okay? So the difference between the equation of a direct variation and partial variation is that plus b value.